Let us start the next session, which is technology session. And Aarti Chame, DV Chame, sir, please come and chair the session. Mr. DV Chame, आइए. Aarti, are you here somewhere? Yes.
Yes, everybody, let's welcome Miss Aarti Chame. जोरदार तालियों के साथ Chief Operating Officer, COO of DVC Process Technologist and associated with the Nielsen Company in 2012 as an analyst of FMCG market study, along with Mr. Gonzalo as founder of LYSPAS and Co Solutions. He designs and implements tailored operations excellence systems.
Gonzalo, are you here somewhere? Please come.
Yes, he is here.
So everybody knows DVC process and Chame साहब तो I think उनके नाम से company चल रही है. Aarti, the Chief Technology Officer, and Gonzalo is a friend of mine from Argentina. He has worked with Cargill and lot of other companies, and he has been involved with quality improvement and how the plant should run and how the process is. I think let us hear from them, क्योंकि आप सब लोग plant चलाते हैं, तो plant में efficiency कैसे आ सकती है, what more can be done, how. So let's hear from them. And Chame sir, over to you. You have to run the session. Please, sir.
Good afternoon, my friends. This SOPA convention, as we are hearing from morning, we are discussing about sustainability. And now sustainability is a very important aspect, and it is not separable in any walk of the life, whether it is a technology, whether it is a day-to-day, working or just farming, that we have discussed on farming also. So every aspect, sustainability means lasting long. There is solutions for lasting long. Is a generally we can say. So in this session we are going to discuss about the sustainability on the process, and my friend Mr. Gonzalez, he's from Argentina, and he's going to present the sustainable solution on seed handling and this processing. So in short, I will discuss on sustainability. That we are, normally we are in the field of providing the solutions for oil processing and seed processing. When you are talking about the oil processing, it's necessary to give complete solutions for the processing, right from the oil processing to its value-added byproducts, or adding value to the byproducts, and then further value addition to the byproducts produced. Like in oil processing, we take up case of soybean oil, crude soybean oil. This, while it's processing, we do have the degumming. During the degumming, we do produce the gums, which is the byproduct which is being produced. That is, after this processing, that we get the lecithin. Lecithin again, with this, after this processing, we can have this de-oiling of the lecithin, and that de-oiled lecithin, we have many applications in the food industry, this right, emulsification and many products, paint industry and all this one. Another product that is soap stock, that is very critical handling of that one, to acidulate it and then handling of that product is very critical. People very much worried about, and is the most neglected part of this oil refining. So that product, how to process, how to get good quality acidulated product by processing that soap stock. Again, a challenge that very much necessary to look at that one and how you can have the quality product so that its further processing will add value to that. I mean, further processing that is, it's producing this, I mean, it's a feedstock for the oleochemicals, and oleochemicals, we know that oleochemicals are the base for the, substitute for the fossil products which are in this petrochemical products. And that is oleochemicals are this used in the surfactants and this, anyway, this paint industry, all this one. So these complete solutions are very important, and also this processing, this making sustainable, it should be what this, in this processing, the major inputs are, apart from this product, input product, another is a major part that is of utilities that is of steam, and that is electricity. And then comes the secondary, there's chemicals and all this one. So now that is, utilities are being considered as a raw material as well because of this higher cost of the inputs, these utilities. We know this steam is being produced from the fossil, that is coal and this, maybe the agro waste and all this one, but still the cost is higher. And electricity, we know nowadays, I mean, state to state, the rates may be low, 10% here and there, but that may be around 10 rupees a unit. And our country is a blessed country. I mean, we have almost 10 years, 9 to 10 months, good sunlight. Till date, this is not being exploited to generate the energy and electricity from that one and use that for the process. Now, how it can be used for the processing, that's, there are many ways. Now, the good way that is, you can have this, government have this facility to have the reverse metering, and you can feed to the grid, and that electricity, you can use it, and off times also. So by that, you can reduce this utility, this electricity consumption cost. Another way that is, it's still working is on, that how to make this processing industry, particularly the agro-processing industry, grid-free, I have to say. I mean, we having our own electricity production and that have storage and then again utilizing. So grid-free is, very wide aspect and wide spectrum it's having. And also the fossil-free, fossil fuel-free. So how it can be fossil fuel-free? So what electricity you generate, so from that you can produce this utility like steam, and that can be used in a process. The initial capex may be a bit higher, but in the longer run, that if you see the working of next 10 years, that capex which you have invested, that will get have the payback in this one, in a shorter. So these are the things about this sustainability and this. Regarding this seed handling and its preservation, in morning we have seen this in India. We have the very heterogeneous, facilities, and because of this climatic conditions and scattered farming, we don't have the industrial farming. We have this scattered farming. So in this one, the quality of the seed is not uniform. So that comes to the extraction plant, and then the processors don't have this quality seeds, what is necessary as uniform quality. So in that, you must have the facility to make that uniform quality. That is a major constant, that is the moisture, and which is a hurdle for processing the seeds. So to take out that moisture and making it convenient to process further, so that is, the seed handling is a very important aspect. Till date in India, it's not much given the importance to that. People are managing somehow, and then also this end products which are being derived, that is maybe the little higher oil content or little higher moisture and all these one. And also this, to preserve the quality of the seeds, the moisture is to be removed, very important, and to produce the feed quality de-oiled meal, that is we have, in morning we have listen that regarding this to make the meal that is usable for making the edible protein. And this, the system is being used, that is a flash desalination. In India, very few industries do have this facility of flash desalination. In Indore, only 2, out of which our company has given. There is the largest capacity in India, there is 700-ton capacity. But now no other have that facility. That what is PDI requirement, that is of 85 to produce this edible protein products, isolates or some other substitutes for the meat or some others being used as a blended one. So this is what is requirement. People have manipulated to have this higher PDI and all that with low price, low capex, but they could not get what its product requirement. So, and the smaller capacity, but the plants can be have a smaller capacities also, so that the 100-ton plant that can be helped produce very well this edible protein, feedstock for edible proteins. So this is the thing. Now you can listen what I have just mentioned, overview on so regarding the sustainability and the seed handling. Thank you very much. So over to Aarti.
Now, ladies and gentlemen, Ms. Aarti Chame on the podium.
Okay, good afternoon, everyone. So today in this session, I'll be sharing some insights into sustainable edible oil processing and how it is shaping our edible oil industry today, in future, and how we can convert our combined environmental promise into long-term business resilience. So before, oh, okay, I forgot about this. Okay, so before delving into the topic further, a briefing about my company, DVC Process Technologies. We are headquartered in Pune, and we are a technology and innovation-driven company that offers comprehensive sustainable solutions for edible oil processing, oleochemicals, and biodiesels. We were established in 2001, and the way we started was upgrading the inefficient process plants to technologically competent and energy efficient plants. We also provide turnkey solutions for establishing new greenfield projects, as well as I said, the upgradation of existing plants. With a competent team which spans across the design, engineering, process design, manufacturing, project execution, electrical, in-house automation, we are able to deliver, or we are able to have over 250 global references. And from past 5 years, we have got really good references for biodiesel processing plant supplies, and we are in phase of installation of at least 4 plants currently, and one of them is 700 tons per day, which is biggest in India, in Vizag. So let's move to the main topic of this session. So what makes any processing sustainable? A process can be called sustainable, which can minimize resource use, resources like energy, water, chemicals. A process that reduces waste and emissions. A process that ensures traceability and quality. And a process that protects ecosystem and environment. We all are aware of these stages in the oil processing, about the sustainability and cultivation of oil crops, We have had a very beautiful session, couple of sessions in the morning, and we had insightful speakers who have given a lot of information on this and how we are moving ahead with it. Then the extraction of crude oil, refining, we'll be talking more of refining in this session, packaging and distribution, and the waste management and valorization. The waste management and valorization will be more covered by my colleague in tomorrow's presentation. He'll be delivering a topic on that. So what can we do? How the industry can contribute into sustainability? We really need to design or select optimum process and equipments which will have low energy consumption. We need to have energy efficient insulation systems. Poor insulation, it can lead to wastage of heat. We all know that, and we really need to check on that. Installing energy efficient systems. Installing heat recovery systems that will lower the overall energy consumption. Optimum use of instrumentation, automation, and artificial intelligence so that we can keep a check on each and every parameter and energy consumption at each and every processing stage. Also, integration of renewable energy sources like solar, wind, hydrogen, biofuels to cover their energy needs. And the very basic thing, doing plantations, a basic thing, and reducing the carbon footprints. So I'll be covering 3 subtopics in today's session. The first one would be the energy efficient processes in fats and oil processing. The second one would be the integration of renewable sources in our plants. And the third would be the automation and artificial intelligence, how it can give a betterment to our industry. So the most heat-intensive or energy-intensive operation in any refining is deodorization or deacidification, wherein we need a temperature of around 240 to 250 degrees Celsius depending upon the oil. But normally for soy, we go for 240 to 250 degrees Celsius of temperature at a vacuum of 1.5 torr. The typical heat regeneration that we see in normal plants is somewhere around 200 and 205 degrees Celsius, which they reach, and for the further heating application, they either use thermic fluid or thermosiphon systems with high pressure steam. However, with upgraded regeneration systems that we normally provide, or we actually provide to every process systems, there's additional heat recovery where you can reach at least 225 degrees Celsius, and then you go for final heating operation by thermic fluid or thermosiphon. The required energy to reach 250 degrees Celsius in this case would be 15,000 kilocalorie per ton of oil, which then gives us a saving of at least 40%. This is how the heat recovery from the deodorized oil and incoming oil goes, what temperatures can be achieved, and how it can further add up to the heat recovery. The vacuum system. Closed-loop chilled water vacuum systems definitely use lesser energy as compared to the traditional ones, which normally operate at 34 or 30 degrees Celsius of cooling water. These systems are less smelly as water is circulating in closed system, and fatty matter overflows continuously, which is very much easier to manage. Then the next wastage that happens is PLF spent steam, which is just vented out into the system or into the environment. However, it's a big wastage, and this needs to be accounted for, and we can heat the boiler feed water with this steam and not just wasting it away. Then the zero liquid discharge plants, wherein we have immense pressure from environmental factors that there should be no liquid discharge from the processing plants, and where the ZLD comes into the picture. But ZLD is also a very energy intensive operation. And the steam that is being released through this system, many plants just again vent it out to the environment. However, this very steam can be used to heat the incoming effluent into the ZLD, or maybe for other operations, for other heating operations. Boiler flue gas heat recovery. Everyone does it, but how efficient it is, it's a question. But it can definitely save like 5 to 7% of the fuel. Then the efficient condensate recovery. Condensate and flash steam contributes a considerable amount of in total energy use. So the collection of these condensate from all the vapors is very much necessary, and pumping this condensate back to boiler. The flash steam from condensate and boiler blowdown can be used to heat the makeup water. And this, by this, we can say that for every 6-degree rise of temperature, we can save the consumption of fuel by at least 1%. If you look at overall picture, it's a big saving in long time. So that was energy efficiency, how we can save the energy in the refining process. Now we are moving on to the renewable power integration. So various renewable energies we can integrate into our system, mostly being solar, hydrogen, wind, and biofuels. But the most prevailing ones are solar, wind, and biofuels, as hydrogen needs more research, and people are starting doing it, but it needs more commercial viability. Okay. So this is a typical solar integration, how it can be done in any processing industry. Through solar panels, we take the power to DC-AC inverter, then feed it to the LT panel of the industry. When the industry is not in operation, we can feed it to the power grid via net metering. A case study for installed load of 285 kilowatt versus 216 kilowatt. If you see, the payback period for this case is 4 years, and that's really good. So return on investment is 24% every year. The next thing that can be integrated is the biofuels. This slide is from one of my presentations that I gave for net zero by 2050 in FOIC 2023. So you would see a couple of things which are not related to this topic. But anyways, so if you see by 2020, biofuels account only for 3% of transport fuel globally. And to achieve net 2050, which is committed by our Prime Minister, Shri Narendra Modi ji, by 2050, we would need at least an annual growth of 14% every year. And very soon, the policymakers would make it mandatory for vehicles to run on 100% biodiesel. But with changing policies every now and then, we don't know how soon can this be done. So the challenges or the concerns in the biofuel, the raw material availability. I mean, the things I have mentioned in my PPT, it's not viable, but definitely the wastage or the byproducts from the processing, that is acid oil or used cooking oil from the market. They are the perfect candidates for raw material for biodiesel, which will be viable and which are viable, and people are running their biodiesel plants on it. And more focus on biofuels produced from waste, which I just mentioned, it meets 45% of total biofuel demand by 2030. And biofuel manufacturing can be easily integrated to any process house, where this will make processors self-sufficient and sustainable for their own energy demands. So we move on to the last subtopic, automation and artificial intelligence. So what is role of automation? Automation, first, it meets 45% of total biofuel demand by 2030. And biofuel manufacturing can be easily integrated to any process house, where this will make processors self-sufficient and sustainable for their own energy demands. So we move on to the last topic, subtopic, automation and artificial intelligence. the automated process control, wherein the parameters like temperature, pressure, flow regulation, pH in the refining units, all the data is being taken into account. These parameters are recorded by the field instruments that are installed into the plants. The selection of these instruments is also very critical so that correct data is input into the system. The PLC and DCS and SCADA systems, they do the real-time monitoring and control the entire plant. Then the safety and reliability with automation, reduced human error, and obviously consistent operations. Automation is applicable for both continuous and batch process plants. It can be integrated at any stage of the installation, whether it be at the start of the installation or the mid of the installation, or if you decide to integrate it at the later stage or maybe 2 or 3 years down the lane, it can definitely be integrated at any point of time. The phases of automation, first phase is just data acquisition with the instruments that we have installed in the field. The second stage or the second phase is running the operations, the running operation or the drain operation or the shutdown operations, which are run by the logical programs which are fed into the PLC or DCS. How automation can be successful? Obviously, with proper selection and installation of field instruments, the appropriate processors and the processes as per the feedstock to be processed to achieve desired product quality and optimum chemical and utilities consumption. The designing of control philosophy also plays an important part. The selection of processors and hardware of the PLC system or DCS system also plays a big role. And it needs to cover the entire range of operations in any processing plant, else it doesn't make any sense to control only one section with the automation and rest are just run manual. The next step ahead is role of artificial intelligence. What artificial intelligence does? It's not just only chatbot or chat GPT, it just throws you answers for the questions that we put in, but the application of this artificial intelligence. It can do the predictive maintenance. With the data it gathers from the automation, it can actually tell you when a system is going to go into breakdown without actually getting into the breakdown situation. It gives you the process optimization. The machine learning tunes refining parameters like temperature, pressure, with what kind of feed, what parameters would be suitable, and you can monitor performance of that as well. Then quality control with vision systems. We have advanced cameras which can actually tell what is the quality of the oil which is being processed, or even the seeds, oil seeds, which we are storing. The supply chain optimization plus artificial intelligence can only work if automation is in place and automation is really good. What are the benefits? Well, while discussing this or while telling you this, we already discussed part of it, but yet again, it definitely gives you higher yield because all the processes are optimized. It gives you consistent quality. Costs are reduced because lower energy and raw material wastage is also reduced. Faster operations, 24/7 automated systems, no manual intervention. Sustainability, yes, that is the core of everything that we do. Less energy and water use and reduced emissions. But the only drawback, at least in current situation, is the high cost for AI integration. But if we see the list of benefits that is giving it to us, it is worth investing. So just to summarize whatever I have talked here is the first, sustainability needs to be a cornerstone for selection of all the technologies and designing processes. Whatever we are running or whatever we are operating with in the plants, sustainability has to be at the core of it. Energy efficient systems are a must. Without that, we cannot reach our goals. Integration of renewable energy sources in processing houses, which is very much easier now with subsidized solar power integration. Government is also giving funds for that, and that is definitely beneficial for each and every one. And the role of automation and artificial intelligence. So, yeah, thank you. And if you have anything to discuss with us, we'll be happy to help you. Please visit us at our booth. Thank you.
Yes, ladies and gentlemen, a huge round of applause for Gonzalo, sir. Come on, everybody, put your hands together. Over to you, sir.
Good afternoon. Looks different from here. Well, greetings to this important audience. It is a pleasure for me, it is an honor as well to be here in your country, in this beautiful India. This is my first time here in the country. We came with my wife 2 days ago, and we are enjoying, you know, how your country is. How intense is India, okay? The food, the stomach are still good so far, but really you have a beautiful place, and I want to thank so much SOPA for inviting me to stay here, sharing my experience with you guys here. Today, let me see. Okay, today we will talk about efficiencies. And efficiencies in our business is something very, very important. And so I will try to honor the word efficiency. I will try to use my time in a very efficient way because, you know, I need to keep you awake after lunch. So the first thing I thought when I came here, say, well, how can we compare the different realities that we have in our countries? I came from Argentina. And we have also a very big crushing business, and I will try to share with you our insights about our problems and how our problems can be similar than yours. So first of all, I'm Gonzalo Luvani. I'm from Argentina. I have more than 30 years experience in the soybean and the crushing business. I worked for Cargill for 30 years. Until I left the company and created my own company. I dedicate my effort to continuous improvement systems. And really, this is something I want to share with you. My last 10 years, I was developing the continuous improvement practices all around the world, leading a global position. And so the question is why companies like Cargill or the big ABCD, you know, ADM, Bunge, Cargill, Dreyfus, why are those companies using continuous improvement practices? And the reason is because they are finding good solutions, you know, at those practices. So the idea is to share with you part of those solutions and see how we can implement, you know, those practices here in your reality. If you want to follow my presentation, you can scan the QR code and you will see my presentation on your phones. You have to go to the English version, okay? And so this can be easy for you to follow. Well, this is India and my country, Argentina. We are very far one from the other, 15 kilometers away, probably 22, 24 hours flight. It was a long flight. This is my homeland. This is Rosario. You can see Messi. I'm sure that everybody knows Messi. Okay, Messi is from Rosario, and you know, in Argentina, everything will relate with football. Okay, so now you will remember me anytime you will see Messi. Okay, that was the Argentinian that was at the SOPA conclave. Okay. But the importance is not Messi. The importance here is this river. Okay, this is the Paraná River that crosses the country from the north to the south. So for Argentina, this river is the same than for the Americans is the Mississippi River. Okay, because everything goes through the river. So the reason because I'm making this comparison is because I want to make a comparison between the countries. Okay, between Argentina and India. And you can see that the size of the country, your country is 1.2 times bigger than mine, okay? But the main focus for our market, especially the soybean and especially all the grains market, is the export, okay? We need to focus on the export. That white dot is the location of Rosario, and you can see that you have to sail the river until go to the ocean, okay? In your case, you are in the middle of the city, of the country, sorry, and you have to focus on the internal market, and that is a big difference. We produce about 53 million tons of beans, okay? And we planted 17 million hectares, so you can see the yield, okay? It's about 3.5, okay? And every year we are increasing, okay? In your case, you are planting 13 million hectares, and your production is about 10 million, okay, of soybean, right? But look at this. This is the capacity that we have, okay, in Rosario. And that is Rosario area. Rosario is a big hub of soybean crushing. So we have 58 crushing plants, okay? We produce 212,000 metric tons per day, okay, of beans. And look at this. This is Rosario. Oh, I'm sorry. Let me go back. So all those facilities are in an area of 60 kilometers, all right? So you can see the capacity of the plants. I'm talking about 20,000 metric tons per day, 14, 10, 30,000, 6, well, 20. I mean, big facilities, okay, big facilities. But look at this. Look at this. So this is the idle capacity, okay? The capacity utilization. So we have so much capacity, installed capacity, but we don't have beans, okay, to supply those plants. So this is the problem that we have, okay? We have a lot of capacity and we don't have beans, okay? So what we need to focus is on the efficiencies, all right? We need to focus on the efficiencies. So same happened with you guys here in India. Okay, you are producing about 10 million tons of beans and probably another 10 of rapeseed. I'm adding some charts with rapeseed because I know that you have plants that you switch between soybeans and rapeseed, okay? What we call the multi-seed plants, all right? So, and this is the installed capacity that you have. It was not so easy for me to understand these numbers, okay? But really, besides the number, these are roughly numbers, okay? The concept is that you also have perhaps 50% of capacity utilization, right? So we have the same problem between India and Argentina, besides the volume, okay? We crush 53 million tons, you crush 10 million tons, but the problem is exactly the same, okay? We need to focus on the efficiencies, and you need to focus on the efficiencies, all right? Are you agree with that? Yeah? Okay. So, what can we do if we want to focus on the efficiencies? I think that part of the presentations before mine, they talk a lot about efficiencies and about how to focus on different variables to see if the process is running in an efficient way, and that is great because that shows that we are in the same line, we are in the same thought, right? So when we talk about continuous improvement practices, okay, we say, okay, this is not only a solution, this is a way how we need to think about the problems, okay? This is not a concrete solution for any particular problem, okay? This is a way of how we need to think about our new problems, okay, and how we need to tackle our problems in a very structured way, okay? So, I mean, this is like a toolkit of continuous improvement, different practices, and I will try to explain to you two of them, all right, in a very short way. But let's talk about Lean and Six Sigma, okay? These are the main two continuous improvement practices that you can apply at your facilities, right? So when we talk about Lean, okay, Lean means waste, okay? Lean means overcost. Lean means how to reduce the inefficiencies. That is the meaning of Lean, okay? It is a Japanese word, And lean, as well as continuous improvement, is like a philosophy. And I think you have to be very open-minded to apply lean practices or continuous improvement practices. And this country, you have a people with a very open mind, okay? So I think that continuous improvement practices are perfect for this country, okay? So when we say waste, right, in our facilities, we can remember, you know, this comes from the books, the 8 famous wastes in the industry, okay, the defects, the waiting, transportation. But what I want to share with you is that when we talk about waste, what we need to do is to identify the waste, all right? So we need to go to the plant, we need to go to the factory and see what is going on there, all right? So this is like a simple map of our business, okay? No matter the volume, this is exactly the same for Argentina or for India, okay? You can see that we have the procurement, the logistics, the operations, the commercial, okay? Then we send different information to the plant, to the storage, to the receiving, okay? So that is a map of our process. So what is my suggestion for you guys is to go to the plant with this map and try to identify the inefficiencies, okay? So what we call a Gemba walk. A Gemba walk is going to the place in where the problems are, right? Go to talk with the people. And once we talk with the people, we start to understand the problems, okay? And we start to see the opportunities, all right? So my colleagues from DVC, they mentioned about insulation, they mentioned about how to read the variables. I mean, those are perfect examples of inefficiencies, but before that, we need to go to the site and see what is going on, okay? So once we go there, okay, we can say, okay, let's try to identify the different wastes that we have. So you can see the blue marks, right? In what I say, okay, we can go to the parking lot to see the waiting problems that we have there with the truck drivers. We can go to the drying to see the extra processing anytime that we dry above the limit that we need to dry. We can go to the checking and sampling and think about the accuracy of the instrument. How important is the accuracy of the instrument? Here I see on the feria that there are many instrument suppliers and that it is so important to check the accuracy because that is the heart of our business, right? Every time that we make we make a sample and then we pay to the farmer according with the quality, right? And the same happens anytime that we sell the product. I have seen the people from SGS over there, okay? What they are doing is checking our goods, okay? So we need to be very accurate, okay? In order to be sure that we are receiving the money according with the quality that we are sending, okay? Those are inefficiencies that we need to identify and then to tackle, right? When we identify these inefficiencies, we need to say, okay, what are the different tools, what are the different practices that we can apply. So here are some examples regarding continuous improvement, like a Kaizen event, okay, like a maintenance plan, like stable operations. So, I mean, there are many different solutions for these problems, but before that, we need to identify the problems. Is that right? Okay, so just to give you an example, if we identify simple problems, low handling fruits, okay, we need to go to the plant and we will see these opportunities, okay, in a very easy way. You can see in a 1,000 tons per day factory, 1% moisture represents $100 a year, okay, 1% moisture difference, and I'm sure that we have that difference in our analysis, okay. The same with the mass balance. Mass balance, what we are receiving versus what we are loading, okay? A 0.5% difference represent in a 90,000 tons per year factory, $1.5 million in a year, okay? So what I'm suggesting to you guys is go to the plant, try to identify the opportunities, okay, and see what's going on. And perhaps I'm just talking about the efficiencies and about the business. You can go there and identify safety conditions, okay, or process safety conditions. In the same way, okay, go do a Gemba walk, work with your people, try to empower your people, okay, try to give the power to say, okay, show me where you are seeing the problems, showing to me what are the pain points that you have in the process, okay, and also you can see the throughput. The throughput, well, now here it is oil extraction, but the throughput is another big opportunity, okay? The throughput is another big opportunity, and I want to discuss throughput using this, using this chart, okay? You can see here, this is a very typical this is a very typical schedule. This is a very typical calendar for a crushing facility, okay? In my country, most of the plants, we run 100% of the time soybean, okay? Only a couple of facilities in the south of the country, we switch to rapeseed, okay? But let's suppose that we have soybean and we have rapeseed, okay? Look at the green period, okay, the dark green. That is the period in where we have the harvest, okay? And most of the time, what happens with the margins? The margins are higher, okay, because we can collect and pay less to the farmers for the grains, right? So in that period is when we have higher margins, and we need to focus on the throughput. We need to focus on the volume, okay? Once we leave that period, we go to the light green. That is a period of deficiencies, okay? The margins are not so high, and you know, guys, that this is not a very high margin business, okay? We are in a commodity business, okay? So sometimes the margins are high, but sometimes the margins are low. So when the margins are low, we need to focus on the efficiencies, okay? Look at these charts, and try to think about yourself where you are here. Perhaps a plant manager view is seeing the monthly throughput, right? And he can believe that the plant is pretty stable, okay? Then the plant supervisor has another different view, okay? He said, well, it is stable, but not so much, right? Let's see what the operators are seeing. This is what the operators are seeing, all right? So this is the operator's view. So we need to tackle this problem, because this is the real problem every time that we are above the limits or below the limits, okay? So throughput in real time. And I want to make a connection with the presentation from DVC in what they talk about how to read the variables in real time. This is so important, to read the variables in real time, okay? Because we can identify the slowdowns or when the plant is down. Most of the time we identify when the plant is down, okay? But the slowdowns are so important in our business that really create the difference. Once we identify with the operators again, okay? Look at this, technology, okay? Technology to read what is going on at the plant. And the operators can read the technology, and they can know exactly what is going on here, okay? And then, you know, the daily contact, lead by the operators, okay? The operators have to lead this problem-solving session, okay? Every single day, because they know what is going on with the process. And once we have the operators, okay, this is what we call the inverted pyramid, okay? We need to empower the people, okay? It is not necessary to send the engineers, okay, or to the plant manager to see these problems. The operators can lead the problems and can find the solutions, okay? And so, besides the technology, you know, it is important to put the people together. You can see different examples at different parts of the world, okay? So next time I would like to see India, picture from India, and so you can see the people leading the meetings, okay? Leading every single day meeting. And this is so important. Trust me that once you do this, the result will change instantaneously. Okay, so once we identify the problems, we can see what are the root cause analysis for each of those problems, and we can start working on them and try to find the final solution. And at the end, we will see something like this. Okay, that daily production that I showed you at the beginning becomes the other one. Okay, this is what we call the stable operations. All right, the stable operations will give you at least 20% production increment, okay, without any capex investment. Okay, this is only operational discipline. Okay, only operational discipline. Well, let's move forward very quick to show the last opportunities. Okay, so to say, okay, we have plenty of opportunities. Okay, we have opportunities on the waste reduction. Okay, we have opportunities on identify all the different problems that we have at the factory, and we have opportunities on the throughput. All right, we need to go for them, and we need to apply continuous improvement practices in order to find these solutions and try to collect the value of these solutions. Okay, so that's the end. If you have any questions, I will be here to answer any of your questions, and we will be here in the area for the next couple of days, trying to visit some plants. So feel free to contact me, and that's it from my side. So I want to say namaste, as it is how you say thank you and goodbye in your language. Thank you.
Thank you so much, Gonzalo sir, for your lovely insights and your suggestions for the improvement in our soybean industry. All right, ladies and gentlemen, and it's time for the felicitation. So I would like to request first, हमारे बीच मौजूद हैं मिस आरती चामे मैम, प्लीज़ आगे आएँ और इन्हें फेलिसिटेट करने के लिए हमारे मॉडरेटर मिस्टर DV चामे सर. क्या बात है, अमेजिंग, एक लवली बॉन्ड और आप सभी के सामने फादर एंड डॉटर, इससे बड़ी बात क्या हो सकती है कि एक डॉटर को यहाँ पे फेलिसिटेट किए जा रहे हैं उनके पिताजी द्वारा. अमेजिंग. एंड साथ ही मैं रिक्वेस्ट करना चाहूँगी मिस्टर गोंजालो सर से, प्लीज स्टेप फॉरवर्ड सर. टेक्नोलॉजी के बारे में हमें बहुत ही अमेजिंग वैल्यूएबल नॉलेज यहाँ पर मिली है, एंड जैसे कि हम सभी जानते हैं टेक्नोलॉजी के बिना आगे बढ़ना बहुत मुश्किल है. और इस सेशन में हमें काफ़ी कुछ जानने को मिला, एंड अब रिक्वेस्ट करना चाहूँगी पाठक सर से टू फेलिसिटेट आर टाइटल पार्टनर, आर टाइटल स्पॉन्सर DV चामे सर. और सच बताऊँ, कल पाठक सर और मीटिंग थी, एक ब्रीफिंग थी, एंड चामे सर आपके बहुत बड़े फ़ैन हैं हमारे पाठक सर, वो आपकी बहुत तारीफ़ कर रहे थे. सो इट्स लवली टू हैव यू हियर. एवरीबडी अपने दोनों हाथों से ज़ोरदार तालियां हो जाएं.